Modern diesel trucks can make more power, burn cleaner, and diagnose themselves better than older trucks. So why can one sensor leave a working truck stuck on the shoulder? The real problem is not one bad part. It is what happens when dozens of systems must agree before the truck trusts itself. When people say modern diesels are complicated, they usually mean more than the engine. There are electronic control modules, networked sensors, variable turbo hardware, high-pressure fuel systems, safety features, and exhaust aftertreatment, all sharing information while the truck is moving, loaded, and vibrating. That complexity did not appear just to annoy drivers. Heavy-duty engines must meet emissions requirements while delivering usable power, fuel economy, and durability. Aftertreatment cleans exhaust after combustion, and electronic controls constantly adjust the engine and emission system to keep those targets within range. An older mechanical truck can look beautifully simple: fewer sensors, fewer modules, and fewer warning strategies. But nostalgia skips the trade-off. Older designs generally emitted more particulate matter and nitrogen oxides. Simpler does not automatically mean cleaner, safer, more efficient, or even cheaper over an entire working life. The part that causes the most frustration is usually the aftertreatment system. Exact layouts vary, but a typical modern on-highway diesel may use an oxidation catalyst, particulate filter, DEF dosing hardware, selective catalytic reduction, temperature and pressure sensors, NOx sensors, and a control strategy tying everything together. First, the diesel oxidation catalyst helps convert certain exhaust pollutants and supports the heat needed downstream. It is not a magic muffler, and it cannot correct an engine that is overfueling, burning oil, or sending the wrong temperature information. Upstream problems can quickly become aftertreatment problems. Next, the diesel particulate filter captures soot in its porous channels. As soot accumulates, exhaust restriction rises. The system estimates loading using sensor data and operating history, then manages regeneration. A damaged sensor, exhaust leak, or engine problem can make that calculation unreliable. Regeneration raises exhaust temperature, so trapped soot can oxidize. Some regeneration happens during normal operation. Some systems command active regeneration, and some conditions may require a parked procedure. The strategy and requirements vary by engine, calibration, and application, so the correct operator manual must control. Soot and ash are not the same thing. Regeneration can burn soot, but non-combustible ash remains in the filter. That ash eventually requires scheduled off-truck cleaning, according to the engine manufacturer. Repeated regenerations cannot remove ash. Enforcing them can hide the real maintenance need. Selective catalytic reduction handles nitrogen oxides downstream. The system injects diesel exhaust fluid into the exhaust, where the urea-based fluid helps create a reaction that converts NOx mainly into nitrogen and water. For that reaction to work, dosing, temperature, fluid quality, and sensor feedback must all agree. DEF is easy to contaminate. Dirt, fuel, coolant, tap water, or the wrong storage container can damage performance or create misleading symptoms. Use fluid that meets the truck's specification, keep it sealed, and handle it with dedicated clean equipment. Never diagnose quality by color alone. Here is where modern systems become difficult. One complaint may involve the engine, aftertreatment, and vehicle network at the same time. A biased temperature sensor can affect regeneration. A leaking exhaust joint can distort sensor readings. A communication fault can make healthy components appear unavailable. That is why a fault code is a clue, not an automatic parts order. The code identifies what the controller detected and under which logic. It does not always prove the named sensor failed. The cause may be wiring, pressure, temperature, fluid, software, or another upstream condition. Start with electrical basics. Weak batteries, poor grounds, loose terminals, and excessive voltage drop can create strange warnings across several modules. Test the power and ground circuits under the conditions that set the fault. A new sensor cannot repair a corroded connection or unstable supply voltage. Then inspect the physical environment. Heat cycles harden insulation, vibration rubs harnesses, road spray reaches connectors, clamps loosen, and exhaust joints leak. A 5-minute flashlight inspection can reveal evidence that hours of staring at live data will never show. Observation guides the test. It does not replace it. Duty cycle matters too. Long periods of idling, short trips, and light load may produce less exhaust heat than steady loaded operation. That can make soot management harder on some applications. It does not mean every city truck is doomed. It means the maintenance and operating strategy must match the work. When the system detects a serious emissions fault, warning lamps and power limiting strategies may follow. The exact timing and severity depend on model year, manufacturer calibration, fault type, and current rules. Do not assume every truck will derate the same way. Respond early while you still have options. A forced part regeneration is not a universal repair. Before commanding one, a qualified technician should confirm the procedure is allowed, the area is safe, and the underlying faults do not make regeneration unsafe or pointless. A failed sensor, fuel problem, or exhaust leak may need repair first. Real diagnosis combines current service information with evidence. Verify the complaint, record fault conditions, inspect the truck, review live data, and perform the manufacturer's tests. Compare pressure, temperature, voltage, and commanded operation. Each result should narrow the system instead of triggering another random part replacement. Software matters as much as hardware. Manufacturers may release calibrations, troubleshooting updates, or service campaigns for known conditions. That does not mean every fault needs a reflash. Use the exact vehicle and engine information, maintain stable battery voltage, and follow authorized procedures before changing software. Repair cost is another real problem. A relatively small sensor may sit behind steps, shields, pipes, or seized fasteners. Labor includes safe access, removal, cleaning, reassembly, calibration, and confirmation, not just the minute spent installing the part. Packaging efficiency for the truck can become the service difficulty for the shop. Parts cost also reflects more than the object in the box. Availability, freight, cores, seals, clamps, fluid, calibration requirements, and warranty coverage affect the total. The cheapest part is not always the lowest cost repair, but price alone does not prove quality. Ask what is being installed and why. Owners still have leverage through maintenance. Use the specified engine oil, coolant, filters, and DEF. Follow the engine and vehicle schedules, including filter cleaning where required. Incorrect fluids, excessive oil consumption, and ignored engine faults can damage expensive after-treatment components long before a dashboard message explains the full story. A careful pre-trip can catch developing problems early. Look for coolant or oil trails, damaged wiring, loose exhaust clamps, and anything recently disturbed. Report warning lamps promptly and note when they appear. Small evidence disappears after a tow, a wash, or several hours sitting at the shop. Give the shop useful information. What happened, when it happened, load, speed, temperature, weather, recent repairs, and whether the problem comes and goes. Photos of warning lamps and visible leaks can help. A clear complaint saves diagnostic time because the technician is testing the right condition from the beginning. Before approving major work, ask about the diagnostic charge and request a written estimate listing the condition, expected parts, and anticipated labor. Ask when additional approval is required. State rules vary. Afterward, request the test results, repair explanation, warranty terms, and the procedure used to verify the fix. Deleting or defeating emissions controls is not a legitimate shortcut for an on-road truck. Federal law prohibits tampering and defeat devices, and state requirements may add consequences. It can also create inspection, resale, warranty, and diagnostic problems. Repair the system correctly instead of turning one fault into several risks. Modern trucks are not automatically unreliable. When the engine, aftertreatment, and operating cycle are healthy, these systems reduce harmful exhaust pollution, while onboard diagnostics can identify developing problems earlier. The honest conclusion is that the benefits are real, and so are the maintenance, training, and repair demands that come with them. If you are buying a modern used truck, do not judge it only by mileage or paint. Review maintenance history, fault history, duty cycle, fluid use, regeneration frequency, and after-treatment service. A proper inspection and diagnostic scan cannot guarantee the future, but they can reveal expensive patterns before you own them. The problem with modern diesel trucks is not simply emissions equipment. It is complexity without the right maintenance, information, or diagnosis. Learn how the system works, respond early, and demand evidence before replacing parts. Follow Roadside Truck for more diesel tips and tell us which modern diesel problem we should break down next.